AP and Honors Chemistry, we're now getting into a subject that's at the center of the study of chemistry, which is the subject of molar mass. We learned that the mass number of an isotope of a specific atom is called the mass number. Example, C12 has a total of 12 protons and neutrons. Each proton and neutron has a mass of 1 atomic mass unit, AMU, so the mass of a C12 isotope is 12 AMU. The weighted average mass of all isotopes of a particular element is called the atomic mass. The atomic mass of carbon is 12.01 AMU. The atomic mass is the number found on your periodic table. But atoms are too small to see and atomic mass units are too small to weigh. So chemists work with large bundles of atoms and molecules called moles. A mole is a specific number. It's 6.022 times 10 to the 23rd. So just as a dozen means 12 of anything, could be donuts or eggs or anything, a mole means that specific number of atoms, molecules, anything that you want. Scientists wanted a large number of atoms or molecules so they could be seen and weighed. But why the number 6.022 times 10 to the 23rd? This lesson will answer that question. A mole is that number there, and it could be of anything. This number is called Avogadro's number. In scientific notation, it is written 6.022 times 10 to the 23rd. Remember, we can think of an atomic mass unit as the mass of a single proton or a single neutron. Here's the problem. We can't measure the mass of a proton, neutron, atom, or molecule on a scale, so what do? Well, an oxygen atom has a mass of 16 AMU. You know that from your periodic table. But we can't measure 16 AMU on any kind of scale. We measure mass in grams, and we have scales for that. So what if we knew how many oxygen atoms it would take to have a mass of 16 grams? Then by knowing the number of grams of oxygen, we would know how many oxygen atoms we have. So there you see 16 atomic mass units, and on the right you see 16 grams. Notice the numbers are the same, but the unit of measure has changed from AMU to grams. So how many is it? Is that a fixed number that will get us from the 16 AMU to 16 grams? How many is it? The answer is Avogadro's number. 6.022 times 10 to the 23rd is the number of atoms that will convert the mass of a single oxygen atom. 16 AMU. The same number of grams, 16 grams. So there you see it right there. And there you see the conversion. And that's true for anything. That number 6.022 times 10 to the 23rd will convert from AMU to the same number of grams of any substance. So this is the atomic mass, and this is called the molar mass. It's the mass of 1 mole, 6.022 times 10 to the 23rd molecules or atoms. The relationship is true for any element or compound by taking the atomic mass in AMU and multiplying by Avogadro's number. So let's take carbon. From your periodic table, carbon has an atomic mass of 12.01 AMU. If you multiply that by Avogadro's number, you get 12.01 grams, something that we have scales that can measure. Nitrogen, 14.01 from your periodic table, multiply that by a mole, and you get 14.01 grams. Neon, 20.18 AMU from the periodic table, multiply that by a mole and you get 20.18 grams. Aluminum, 26.98 AMU, multiply by a mole, 26.98 grams. Sulfur, 32.07 AMU, multiply that by a mole and you get 32.07 grams. Here are some common examples of chemical molecules and compounds. So H2. What H2 means is 2 hydrogen atoms are covalently bonded to form 1 hydrogen molecule. H2O, one oxygen atom and two hydrogen atoms are covalently bonded to form a water molecule. CO2, one carbon atom and two oxygen atoms are covalently bonded to form a carbon dioxide molecule. You know these are covalent bonds because everything you see there are nonmetals. Hydrogen, oxygen, carbon are all nonmetal to nonmetal. NaCl, that's one sodium atom and one chlorine atom. That's an ionic bond. Sodium's a metal, chlorine's a nonmetal. And that forms a formula unit ionic bond. O2, two oxygen atoms are bonded to form an oxygen molecule. That's a covalent bond, and it forms a molecule. The small number after the atoms is called the subscript. A subscript of 1 is not written. So remember that term. Learn that term subscript so you know what it means. H2 and O2 are covalent bonds that form molecules. They are not compounds because they have only one element. If a number appears in front of a chemical formula, it means that there is more than one molecule or formula unit of that formula. So here's 2H2O means that there are two water molecules. There are 4 hydrogen atoms and a total of 2 oxygen atoms in the 2 water molecules. 3CO2 means that there are 3 carbon dioxide molecules. That means that there are 3 carbon atoms and a total of 6 oxygen atoms in the 3 carbon dioxide molecules. 4O2 means 4 oxygen molecules. So there are 8 oxygen atoms in 4 molecules of oxygen. The large number in front is called a coefficient, just like in math. It indicates how many of the complete units you have. The atomic mass of a molecule or unit cell is computed by adding the atomic masses of each atom times the number of atoms. In moles, this is the same, but the number is measured in grams. Atomic mass is a single water molecule. Okay, so here you have a water molecule. You have 2 hydrogens. Each has a atomic mass of 1.01 AMU, and then you have an oxygen, which has an atomic mass of 16 AMU. When you add that up, you get 18.02 AMU for the mass of a single water molecule. So you get all of these numbers off the periodic table. The molar mass of 1 mole of water molecules, that is 6.022 times 10 to the 23rd, you notice everything is identical as above, except we changed the units of measure to grams, something that we can actually measure on a scale in our lab. The unit of measure changes from AMU to grams, which we can measure on our classroom scales. For more than 1 mole, you can count the number of moles of each type. For example, you have 2CH4. That means you're going to have 2 carbons. Each one is 12.01 grams. A mole is 12.01 grams. And then you have 2 times 4 or 8 hydrogen moles of hydrogen, which is 1.01 grams. You simply add all those up and you get the mass of 2 moles of CH4 is 32.1 grams. We now think of these numbers as molar mass. So we're going to get away from thinking of individual atoms and molecules and thinking of moles, these big bundles, these big baskets of atoms and molecules that we can actually see and measure. Okay, so we're going to look at a table and we're going to show a way that we can get from atomic and masses over to molar masses. So for water, for example, we start with hydrogen, oxygen, and the 2 of them combine to form H2O. So how many atoms? Well, we have to have 2 atoms of hydrogen, 1 atom of oxygen. Now they don't add up to 3, they add up to 1 molecule of H2O. In other words, 2 wheels and 1 seat is needed to make 1 bicycle, not 3 bicycles. All right, now the atomic mass unit there is from the periodic table is 2.01 times 2 times 1.01 is 2.02. For oxygen, it's 1 times 16, and when you add all that together, you get 18.02 atomic mass units. Now, if we multiply the number of atoms and molecules of hydrogen, oxygen, and water, we get, by 6.022 times 10 to the 23rd, we get 2 moles of hydrogen. We get 1 mole of oxygen, and we get 1 mole of water molecules. Now that would be true no matter what number we decided would be a mole. But it's the next column that's significant, because what you can do is simply take the atomic mass unit and convert it to grams. So 2.02 AMU becomes 2.02 grams, 16 AMU becomes 16 grams, and 18.02 AMU becomes 18.02 grams. So what this is saying is, to make 1 mole of water, you need 1 mole of oxygen, 2 moles of hydrogen. In terms of mass, you would need 2.02 grams of hydrogen to make 1 mole of water. You need 16 grams of oxygen to make 1 mole of water, and that would produce 18.02 grams of water. So let's do some problems here. How many grams is 3 moles of H2O? So you see that one mole of H2O is 18.02 grams, so if you want 3 moles, you just multiply that by 3. It's like if you need a certain ingredient to make 1 cake and you want to make 3 cakes, you need 3 times as much of that ingredient. So 3 times 18.02 grams equals 54.06 grams of H2O in 3 moles of H2O. The way I wrote this as a complete sentence is the way I would like you to do it on the assignment, okay? Don't just give quick calculations. Show that you understand these relationships by writing it as a sentence. How many moles hydrogen are needed to make 4 moles of H2O? Well, if we look at it, to make 1 mole of H2O in that small red box, look up above, you need 2 moles of hydrogen. So if you want to make 4 moles of H2O, you need 4 times 2 moles of hydrogen. That's 8 moles of hydrogen, and that's what's needed to make 4 moles of H2O. How many moles of O are needed to make 3 moles of H2O? Okay, so you need 1 mole of oxygen to make 1 mole of H2O. So to make 3 moles of H2O, you need 3 moles of oxygen. And that's needed to make 3 moles of H2O. How many grams of oxygen are needed to make 3 moles of H2O? Well, to make 1 mole, you need 16 grams of oxygen. So to make 3 moles, you would need 3 times 16, or 48 grams of oxygen to make 3 moles of H2O. How many grams of hydrogen are needed to make 7 moles of H2O? So you need 2.02 grams for 1 mole of H2O. So to make 7 times that much, you need 7 times 2.02, or 14.14 grams of hydrogen needed to make 7 moles of H2O. So here's the molar mass for water as H2O. So we've seen that before. It's 18.02 grams for a mole of water molecules. This can be written in several ways, and you need to become familiar with these because you're going to see all of them in problems going forward. So this is called an equivalency. It says that 1 mole of H2O equals 18.02 grams of H2O. So it just sets 1 mole equivalent to some number of grams. For water, it's 18.02. Then the shorthand, the way you'll often see it in a problem, is the molar mass of H2O equals 18.02 grams per mole. That means 18.02 grams of H2O for every 1 mole of H2O. But that's kind of a shorthand way of writing it. And finally, the way you're going to need to use quite a bit are the conversion factors. And you create conversion factors simply by taking the equivalency and putting one side over the other and then flipping it. So 18.02 grams of H2O for every 1 mole of H2O, that's a true statement. Or there's 1 mole of H2O for every 18.02 grams of H2O. It's basically saying the same thing in 2 different ways. And we'll see what the significance of that is very soon. Alright, so that takes care of our lesson on molar mass. This is how we get from the molecular atomic level to big bundles that we can actually see and work with in the lab.